first off, do you guys remember the tangent function? Okay, like the most basic idea of it. How did it look? What did the tangent function look like? Yeah, good job. Okay, little squiggly thing. So much different than the sine and cosine, right? And each of the little squiggly things was separated by what? Asymptotes, okay? So it's important for us to keep general shape in mind because we're using our parent function to give us points, but if we don't know how to like connect those points, then it's probably going to be more difficult for us, especially with the tangent function because the shape is a little bit odd. So if you guys remember when we made the parent function for tangent, what was the period for the tangent function? So for sine and cosine, the period was always 2 pi. Okay, amplitude was always 1 for the parent. So unless we had horizontal stretching and compressing or vertical stretching and compressing, we kept that period in amplitude. What was the period we calculated for the tangent function? How long did it take for that to repeat when you guys looked at it in your investigation or on the one we drew on the previous classwork paper? Anybody remember? Take out your classwork 1 if you have it and look. So that has like a graph, 1 sine graph, 1 cosine graph, and 1 tangent graph. So take that out and look and try to remember how long did it take for the tangent graph to repeat itself. So for sine and cosine, it took 2 pi. How long did it take for tangent? This video is going to be long because we got to wait for you guys to get it out. I'm just kidding. Sheridan, are you willing to share with us? Okay, yeah, say it louder. Pi. So remember for the tangent graph, I made you plug in like a bunch more points, okay? And that was because if we plugged in the same ones as sine and cosine, we didn't really see a pattern. We had to plug ones in between because it actually took less time for it to finish one cycle. So when we look back at that, okay, we remember that the period for the tangent graph is pi. So what would we say is the frequency then for something like that? 1 over pi. And you're not really going to see us use frequency a lot for tangent. We're doing it in our notes to make a point about the relationship, but you're really going to use it a lot in your project. Okay? That's why we're setting that up. Okay, what about amplitude? So just a reminder, you guys said the tangent function has these asymptotes, and in between the asymptotes, it has these squiggly lines. Okay? So talk with like the person next to you, we'll say like your shoulder person, okay, since we don't have our group set up, and figure out what do you think the amplitude is of the tangent function. So just take 30 seconds. What do you think is the amplitude? And then we'll see if we're right or wrong or what. All right, anybody want to share with us a guess? Totally a guess, no judgment, right? Claire? 1. Okay, so fair guess, right? Genevieve?
They suggested all real numbers.
Okay, all real numbers. So those, how many of you agreed with 1? 1 is where you were headed. Okay, give me some rationale for why 1. Because that happened with sine and cosine. Yeah, Claire? Uh-huh. Okay, so Claire has good rationale, right? She said, we looked at A before to get the amplitude. A is 1 in a parent function. I feel like it's 1. Okay, fine. All right, why all real numbers? Because they said so, Genevieve. All right, why do you guys think all real numbers? Because they go on forever. So remember how amplitude was defined? Do you guys remember a little picture in the investigation? You guys had a picture like this, and it marked off a part like this, and it said that was amplitude, okay? From like the middle of the wave to the top, or from the middle of the wave to the bottom, okay? We can still establish kind of a midline across our tangent function where we feel like the middle is, but does it have like a top of the wave feature or a bottom of the wave feature? No, it does have places our points were moved to, and there still is no vertical stretch, and they were moved 1 away still. But those aren't the places where our graph turns around. They keep going. So though our rationale for like using A is good, it doesn't make sense with the definition of amplitude, so we have to let go of that part for tangent function, okay? So all real numbers is a good idea, except for that means you're telling me this measurement is all real numbers. So though I understand what you're trying to say, like the function is reaching all real numbers, it doesn't really make sense either with the definition of amplitude. So this is actually a little odd. I was tricking you, I guess. There is no amplitude for the tangent function, okay? So every time you graph a tangent function and I ask you for the amplitude, no matter what the a value is or anything like this, your answer is automatically going to be none. And it's basically because tangent doesn't have this structure at all, right? So it doesn't have a way to measure the way we've characterized amplitude, okay? There is an a value in these other things, it has other properties, but it doesn't have a specific way to measure the thing that we defined as amplitude, okay? Is that all right with everyone? All right, now, you guys already made parent functions, but for tangent, we plugged in like, I don't even know, it looked like 20 points or something like that. That's clearly not going to be an effective way for us to get a parent function on our paper. So we're going to try and use the idea the same way that we did with sine and cosine. With sine and cosine, we knew we wanted points through one period of the graph, which was one entire lap around the unit circle. So we went from 0 to 2 pi, and we stopped every 90 degrees because those were easy sine and cosine calculations. Because the tangent only has a period of pi, we don't want to go all the way to 2 pi. We only need to explore points from a starting point of 0 until pi. But we still want as many points as we had before, otherwise we're not going to see some patterns, okay? So before, we went from 0 to 2 pi, okay? We started at 0 as point number 1, and we stopped every 90 degrees. 2, 3, 4, back here, 5 points. So our parent function consisted of 5 points, right? We still want our parent function to consist of 5 points, but we only want to go from here to here, okay? So what do I want to kind of count by or stop every how many degrees if I only want to look from 0 to pi or 0 to 180 and have that consist of 5 points, okay? So I have a beginning point, right? I have an ending point. I need 3 points in between. What would be good increments for me to explore? Places where the tangent is easy to calculate and also kind of splits that half circle up into equal sections. 45s, right? If I stopped at 45s, I would get here, here, here. Is that okay with everybody? What are 45s in terms of radian? Like, I'm not going to write 45 right now on my chart. What am I going to write? What's 45 degrees in radians? You can cheat and look at your unit circle. We use it. Pi over 4. Good. So basically, we're going like every pi over 4, okay, from 0 to pi. So 0, 1 pi over 4, 2 pi over 4s, which reduces to pi over 2, 3 pi over 4s, and then 4 pi over 4s, or pi. Okay? So you're going to have to memorize this, or at least use the strategy that we just used. Maybe you'll remember this little, like, I want to go from here to here with these 5 points, and that will just help you recall 45-degree increments, and you'll have that. Okay? If we go calculate the tangent at each of these points, so here y divided by x would give us 0. At the 45-degree marks, besides just being nicely splitting up the section that we're looking at, it's also super helpful because the x and the y are the same coordinate, right? So if you take something and you divide it by itself, you end up getting 1, okay? So a tangent that's easy to calculate. At pi over 2, okay, we have the coordinates 0, 1. So y divided by x, 1 divided by 0, would be undefined. A little weird, but not unexpected for us, right? Because that's why this function had these asymptotes here, because it had the places that it was undefined at. And then 3 pi over 4 is over here. Again, same x and y coordinate, so we'll get a tangent that's equal to 1. However, what's the difference between the tangent calculation in the first quadrant compared to the tangent calculation in the second quadrant? -1, right? Because the x is negative, but the y is positive. So even though the numbers are the same, we'll have a positive divided by a negative, and we'll get -1. And then over here at pi, y divided by x would give us 0 again. Okay? We want to see that same y value come back because we want that to be the end of the first cycle, and then we want to be able to go through that pattern of points to get the second cycle again. Okay? Is this all right with everybody? Okay. What are we going to scale our axis by? So what are some ways we could figure out how to scale our axis? So I have weekly reviews to give out to some of you, and then like a couple of the errors that were made. We're not plotting points wrong for our graphing, but because we didn't have it scaled right, the points didn't seem like they were right because we had it like spread out weird, okay? And scaling was something that's difficult for us with these values, right? So what was one option for me to know how to scale the axis? What have you guys been doing with sine and cosine graph? You get a chart of points, you want to plot the points. This will now not be different, okay? We want to figure out how to put those points on here using those x values. Do you know what I mean? Good. So one way we looked at this was the way that we're graphing the number of points we're getting starting at 0 and then 4 other points to represent a period, then it would make sense for the length of our period to be the 4th mark on the graph. How does that help us figure out then the individual scale of each mark on our graph? What can we do with the fact that we've marked the 4th mark on the graph as pi, our period for the graph? Yeah, we can divide it by 4 to figure out what each one should be, okay? So pi divided by 4, or pi times 1/4 would be pi over 4. And then we can just count by that amount every time we move over a mark on the graph, right? So this is 1 pi over 4. The next one would be 1 pi over 4 plus another pi over 4. So 2 pi over 4, which reduces to pi over 2. 3 pi over 4. 4 pi over 4 is our pi. If those don't match, I have a problem, right? I did something wrong somewhere, so it's good that they match. And then it would continue 5 pi over 4, 6 pi over 4, and reduce that. 7 pi over 4, 8 pi over 4. Okay. And now I'm going to put the points on, but I'm going to warn you guys ahead of time. Because the tangent looks like this, we might have a little harder time seeing the pattern than we did with sine and cosine. Okay? So I'm going to put 0, 0. Since I'm still using 1 and -1, even though it keeps going, I'm just going to go ahead and scale my y-axis by 1. Okay? Pi over 4 is with 1. At pi over 2, it was undefined. So that's the place that I want my asymptote. Okay? At 3 pi over 4, it was -1. And at pi, it was 0. Now, here's where knowing the shape comes in and understanding repeating patterns, okay? 0 is kind of your midline of the graph. See how points are coming back to 0? Some are above 0. Some are below 0. That makes 0 the middle, okay? 0, when you go to the right of it, the point you have on the midline at 0, when you go to the right, you have a point above that. Then you have an asymptote. Then you go low, and then back to 0. That's one cycle. What's supposed to happen at the mark after you hit the middle line again? After that, it's supposed to have a mark above it, okay? So before you get all ambitious and just start putting asymptotes in and random points, make sure that you realize this is the same as this point, and when you go over, you're supposed to match up with the pattern that you're seeing in the cycle. So it should have another point that reaches up to 1. Then what should happen after that point when we go over again? Now I should have the asymptote, okay? So the reason I'm showing you this is if we just drew in the points we had, it's not going to be probably what your eyes are happy seeing about the tangent function. It is the tangent function, but it's like a picture of, it's like a snapshot of this part of the tangent function. Like half of this wave that you wanted to see, the asymptote, and half of this wave. Okay? So you have a couple of options. You could actually choose to use some different parent function points if you wanted to. You could start with like -pi over 2, -pi over 4, 0, and like line it up. Or just be really careful about finishing your pattern once you've plotted it, right? That's what I did here so that I could then see the rest of the tangent graph. And maybe now I understand and it's a little more pleasing to my eye what's going on, okay? If I were to continue the graph in this direction, okay, I have the point above 0, have the point at 0. If I'm going to the left, the next point should be down at -1. And then another section after that should be the other asymptote, okay? And there are going to be some patterns that you catch on to, okay? Like the fact that every period we're graphing 5 different points. So that means if we're going asymptote to asymptote, there should be 3 other points or calculations in between because we've specified that number of calculations in our one period of the graph right here. So those characteristics will help make sure that you guys get the pattern right. Okay? Besides the changed parent function, period, the amplitude, okay, everything else that you're going to do with the tangent function is the same. Same transformations, same way we set up the equation, same way we go through and scale the graph and stuff like this, okay? So I'm going to put up an equation for you guys, and we're going to rewrite it, and then we're going to let you guys kind of attempt getting some points and stuff like that on the graph, okay? Let me know if it's okay to take this off, because when I push the button, it's going to erase all of my work, okay? Anybody still need to copy some of this down? Alyssa. Yeah. Yes. Once like the scale part right here? Yes. So I marked the period at the 4th point from 0 because the way that I've set up my parent function, I know that I've set up these 5 points, and if you start at 0, 4 points later, like I specifically picked this many points to complete one cycle of the graph. So even if it gets moved over or whatever, I know if I start at 0, then 4 points later, it should complete one period of the graph. So I know that that should go from 0 to the period of the graph. After that, I need to know what each individual mark is. So since that's 1, 2, 3, 4 marks over, I want to take this and split it up into fourths so I can understand how much each one is individually. Okay? So you can always mark your period there and then split it up into fourths. We had some other ways that you guys could look at the X values and do it too, but if that's the way that you've been relying on, that will work. Okay. Anybody else still need this screen? All right. Okay, so we're going to go to your tangent example if you have the note guide, so we've already done the cosine example. Otherwise, just add it into your notes where you're taking them. We already did the sine example. And now we're going to look at the tangent example. Right there so you can see the equation. Okay. So I put the fractions into the equation on purpose, right, to try and grow comfortable with those shifts, okay, left and right that aren't like whole number values. So remember that because this equation, I'm going to help you guys rewrite it, and then I'm going to let you guys work on the tables and the scaling and stuff like that. So I want to rewrite what's inside here because there's a b value, right, which means I'm not clearly seeing my x minus h group, and we've only studied our horizontal transformations as specifically part of like something called x minus h, like 1x minus h. So that negative half is messing that up. So I want to separate the negative 1/2 so I can build an x minus h group, okay, like we talked about before. What's going to be left in that parentheses when I've factored out this negative 1/2? So x, because I specifically chose that negative 1/2 x divided by negative 1/2 would just leave me with x. What is going to be left here where I before had negative pi over 4? Okay, I hear 2 pi over 8. See some squinty faces. All right, so what do you do if you're stuck on something like this? Like it's not intuitive, you can't just see immediately what you're doing, okay? So think simple, right? If you're trying to factor out 5x minus 10, you factor out the 5. What's left here? X minus 2, right? Okay. So think about what you really did to get x minus 2. You had 5x minus 10, you factored out a 5. What you're writing is 5 times what's left when those terms were divided by 5. So 5x divided by 5 left us with x. Negative 10 divided by 5 left us with negative 2. If worse comes to worse and you can't see what it's supposed to be because it's fractions and it's confusing or whatever, you need to use that idea. I took what was there, I divided it by what I'm factoring out, and then I write down what I had left. So what was there was negative pi over 4. I divide that by what I'm factoring out. What did I factor out? Negative 1/2, right? And then you have to do a little bit of fraction arithmetic. Hopefully at this point you're growing a little bit used to it, right? So I'm going to get a positive pi over 2, okay? And if you're a little uncertain at the end, check that it makes sense, right? If I distributed this back in, would it look the way it looked before? So I'd have negative 1/2 x. And when negative 1/2 multiplied pi over 2 in the numerator, I'd have pi. In the denominator, I'd have 4. And a negative times a positive would make a negative. It seems to make sense with what was there. Okay? All right, so what are our transformations? You guys write them down as we list them here, and then we're going to let you guys try to make tables and stuff like this. So somebody give me one transformation based on the numbers in this equation that are different from the parent function. Genevieve. Okay, right pi over 2?
Nope.
Left pi over 2. Okay. Yeah, so the formula is we studied x minus h, right? This is really like x minus negative pi over 2, making our h value a negative pi over 2 and shifting us to the left pi over 2, okay? All right, somebody give me another transformation. So we've written down shift left pi over 2. What else? We've accounted for this number in the equation and what it does, okay? But there's other things here. Some. Good. Okay, this 1/3 right here is a vertical compression, right? It's taking all the y distances, multiplying them by 1/3, which is moving them closer to 0 or making them shorter and compressing them back. So we're also going to list that we have a vertical compression. Okay. All right, so we have accounted for what the 1/3 is doing to our graph, what this pi over 2 is doing to our graph. What else is happening up here? Yeah, Natalie. Good. Okay. And you chose the tricky one, so good job. Okay, so if we look at the 1/2 right here, it says 1/2, but we studied it on our investigation, right? It doesn't actually cut the distances in half. It actually makes the distances longer horizontally. So we actually use it like a 2 when we're calculating our transformations. And so this 1/2 accounts for a horizontal stretch of our graph, okay? So we've accounted for every number here, but not the negativity of this number right here. Emily? Good, reflection over the y-axis. So this negative is going to change the signs of the x-coordinates. When we change the signs of our x-coordinates, we're reflecting over the y-axis, okay? All right, are we okay with the words for the transformations? And then hopefully those words will help you put together a transformed function table. So we just did your parent function table, so write that down. Try to come up with the transformed function table. Fill in your characteristics like period, phase shift, amplitude, okay? And then see if you have an idea of how to scale this graph or how far you can get, okay? And you can either work with the people. So as we kind of look at your table, one comment about the y value. So you had to multiply those by 1/3. Most of you are fairly comfortable with that. Here's what we get. The one thing that might be new to you is trying to use the undefined value. But the one cool thing about having an undefined value is it is undefined, so you can't do any arithmetic from it. So if it was undefined here, it's not like you can do any of this stuff with it. It's still undefined. Okay? So that will kind of make one less point that you actually have to do any calculating with. For the x value, so most people were pretty comfortable with plugging in 0, getting negative pi over 2. Remember to just take your time and be patient with yourselves and be willing to go through the fractions. So when we plug pi over 4 in, okay, we're doing negative 2 times pi over 4 minus pi over 2. So the first thing that's going to happen here is the negative 2 and then negative pi over, or the pi over 4 will reduce. So we'll get negative pi over 2 minus pi over 2. Okay. So they have a common denominator already of 2. So it's like negative 1 pi plus another negative 1 pi. So we're going to get negative 2 pi over 2, which reduces to be negative pi. All right, so we're going to do this again with pi over 2. Okay. When you do this here with pi over 2, you're going to see the 2's cancel out again here. So you just have negative pi. So remember, if you're struggling with the whole number, write it as a fraction with the 1 as a denominator, and then make that common denominator that you need. So when this is multiplied by 2, so will this be? So now they have a common denominator of 2. Negative 2 pi plus negative 1 pi is negative 3 pi over 2. So I do the same thing with 3 pi over 4. So I'm going to plug it into the same spot. So 3 pi over 4. Again, the 2 and the 4 can cancel and leave us with negative 3 pi over 2. Okay, these already have a common denominator of 2. Negative 3 pi plus negative 1 pi is giving us negative 4 pi over 2, which will be negative 2 pi when we reduce it. Okay. Then we do it one last time with pi. Okay. When we plug pi in there, we have something that looks like this. And again, remember, we make it a fraction so that you can be more comfortable with it and make a common denominator. So if this is a 2, then this is now a 4, and negative 4 pi plus negative 1 pi is negative 5 pi over 2. Okay. All right, what is the period of our graph? Did anybody figure that out? Emily? What'd you get? No, you changed your mind? Okay, so common thing is to pick the last number here, but the last number here is only the period if the chart starts with 0. Then that measures the whole cycle from 0 to here, and then that would be the period. But since we didn't start at 0, the wave's been moved over, and this last number doesn't represent the measurement of the cycle. It's just how far this example ended from 0, but it didn't start at 0, so we can't use that number. Eric? 2 pi. Okay. Do we know where he's getting 2 pi from? What is the parent function period for tangent? Pi. Okay. What is the transformation that affects period? Remember, period is how long it takes me to complete a cycle. So what can change this length of my cycle right here? Yeah, this stuff that we saw in our investigation, right? So horizontal stretching and compressing. So you can look in your chart or what you wrote down. So B value and how it affects the graph. So that B value of 1/2 actually took distances and multiplied them by 2. So our period used to be pi, but just like how all the points got stretched out by 2, now that length that was our period is getting stretched out by 2. So remember, this is going to get multiplied by 2 to give us a period of 2 pi. So the frequency, we would just use the reciprocal of that. And again, this isn't going to be a huge thing for us with tangent. It's going to be more for wave-like shapes like sine and cosine when we're doing our project. Okay. And then what are we going to write for amplitude? None. Good. Okay. It doesn't matter if it was shifted or stretched or any of that because it doesn't have the wave-like characteristic needed to measure amplitude. Okay. And then phase shift is the same thing as what kind of transformation that we've talked a lot about. Phase shift is exactly the same thing as what transformation that we list when we list all the math transformations at the beginning. Sierra? Good. Our H value, our horizontal translation. Okay. So the fact that we shifted to the left pi over 2, we can just write that here. Okay. All we're trying to do with this is get you used to that wave language that we're going to use in our project. All right, so now we need to get this onto the graph, okay? I'm going to take a picture of our points because they're going to erase when I go up to my graph. What are we going to scale our graph by? Okay, so I hear pi over 2. People on board with that? Okay, how do we figure that out? Why do we feel like pi over 2 is a good scaling of our graph? Kyle? Okay, so one way to know that is when we look at the pattern of the points, the horizontal change between every pair of points is pi over 2. Okay? How would we figure that out mathematically? What did we talk about? How would you know these are pi over 2 apart? If it didn't just pop into your head because you're not good at counting fractions or whatever. You could do this one minus this one, or you could do this one minus this one, or you could do this one minus this one, or you could do this one minus this one, And they would all come up with the same thing as being pi over 2 increments apart. Okay, so that's one idea. Serena? What's that? Not the pi over 2 by 4, but the other way to do this is what's our period of our tangent function in this instance? 2 pi, right? So we talked about the other way of doing this is going to our graph. Okay, starting to create our graph and labeling that fourth point, because we know we've set up one cycle to like start and go through then 4 other points past the starting point as the period, which was 2 pi. And if my fourth mark is 2 pi, then the way I figure out my first mark is taking 2 pi and dividing it by 4 or multiplying it by a fourth. So 2 pi times a fourth is pi over 2. Okay? So both those ways can determine how I count my scale, and then we would label by pi over 2. So 1 over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. You can keep going, and we can have all those negative values reflected on this other portion of the x-axis. Is everybody okay with how we got our scale? So we talked about 2 different ways to figure out our scale. They were the same 2 ways we've been using with sine and cosine. We're not changing that idea. Okay? We're just doing it with a tangent graph here. Okay, so then I'm going to go ahead and plot our 5 points. I'm not ignoring you or texting my friend like you guys often do to me. I'm looking at the points I just took a picture of, right? All right. Or maybe I'll text my friend. No, I'm just kidding. Okay, so negative pi over 2, 0. Negative pi, positive 1/3. So I'm with that about there. Negative 3 pi over 2 was undefined. Negative 2 pi has a point at like negative 1/3. And then negative 5 pi over 2 has a point back at 0. All right, and then I have in my head this like squiggly line picture with like the asymptotes in between them because I know I'm graphing tangent, right? All right, so it might be hard to fill in points right now or curves, okay? We might put things in the wrong places. So remember, we want to go through the pattern, right? Where does it seem like the middle point is resting as far as the y values? Which one's kind of the middle, meaning it has some points above it and some points below it? So like, is this the middle point right here? No, because nowhere in my pattern did any points get graphed above that, okay? So 0 is where I see my middle points, right? Because I have them with points graphed above them and with points graphed below them, just to give me some context of what I'm trying to sketch here, okay? So if I follow the pattern the way I just graphed it this way, I was like at the middle, and then I was above, then I had my asymptote, then I was below, I was back at the middle, so now I'm starting again. So when I go over to this next point, where should I plot a point? So I'm back here at this point. If I move over 1 to the left, where should this point be plotted? Above at that 1/3 that we were looking at, right? Okay, so now this one here is this. I have this. The next time I move over, I should have an asymptote, right? Okay, let's say we went the other way, right? Asymptote, okay? Point above, point at 0. Next time I move over, the point should be below. The next time I move over would be the next asymptote. I'm trying to follow patterns from the first cycle that I set up on the graph, right? Once I follow the patterns here, you guys might see a much better way to sketch in those curves that you expected. Now I see better. I see chunks of asymptotes, right? I know the curves go in between them, and I have 3 guiding points to follow. So I know I'm going to draw something like this, and then something like this. And then if I wanted to draw more periods of this graph, I could continue. Okay? Is this idea okay with everybody? Yes? Okay. I'm not going to take it off.